All right, let's knock out some inverse homework. So find the equation for the inverse relation algebraically. Remember to switch the x and the y. Okay, so the process is going to go like so. We have y equals 7x minus 6. All right, step 1 is going to be to swap x and y. When you swap x and y, now we solve for y. I'm going to add 6 to both sides. So x plus 6 is equal to 7y. And then we isolate the y by dividing both sides by 7. So final answer, I'm going to rewrite it to where y is on the left. So y is equal to x plus 6 over 7. This is the inverse. X plus 6 over 7. So step 1, again, we swap x and y. Isolating y. So add 4 to both sides. So x plus 4 is equal to y squared. All right, to get y by itself, I have to take a square root of both sides. And always remember plus or minus. Always plus or minus. So our equation is going to be y is equal plus or minus square root of x plus 4. Okay. Number 3. Swap x and y. Right, it gets very repetitive for sure. Right, doing the same thing over and over. So we swap x and y, and now we solve for y. So I'm going to add 6 to both sides. So x plus 6 is equal to y plus 5 squared. All right, I got to get to the y. So I'm going to take a square root of both sides, and that cancels out the square on the right. So don't forget about plus or minus. So I'm going to get plus or minus square root of x plus 6 is equal to y plus 5. All right, getting y by itself, we have to subtract 5 from both sides. So final answer is going to be y is equal. So you could write either the negative 5 first or the negative 5 last. It truly doesn't matter. Negative 5 plus or minus square root x plus 6. All right. I guess something I failed to mention. Since you have the inverses, it's not necessarily y. It's going to be, here, look. We can do it like this. That's not the notation, right? Because this can be misunderstood because we started out with y. The inverse has a very specific notation. So f inverse of x is equal to x plus 6 over 7. So f inverse, that is the notation we use to signify that it's the inverse of a function. So actually all of these, the notation should be f inverse of x. Right. Once you get y by itself, the last step is to change the y physically to f inverse, because that's really what it is f inverse. So f inverse of x, and then negative 5 plus or minus root x plus 6. So that's truly the answer. All right, we'll remember that going forward. All right, so number 4. We swap x and y. So x is equal to square root of y plus 2. All right. To get to the y, it's trapped inside of the square root. So I have to square both sides. But I have to square the right-hand side to undo the square root. But whatever I do to one side of the equation, I got to do to the other side of the equation. So we're going to get x squared is equal to y plus 2. Right? It's no longer in the square root. Minus 2. Y is equal to x squared minus 2. So since y is all by itself, it's isolated, we say f inverse is equal to x squared minus 2. F inverse. All right, number 5. Swap x and y. Negative 4y minus 1. All right, couple things here. We're going to multiply. Right, there's a negative. I can't square it. I say that I can't square it, but now I think about it, I could square it. Right, this is one of those cases where I could square it right away. Because if I square it right away, it's going to square the negative, right? Negative 1. Negative 1 times negative 1 is positive 1, so technically it's going to go away. Because even if I didn't square it, right? Even if I didn't square it, and I multiplied by negative 1 first to get rid of the negative 1, well, then this is going to be negative. And then when I square it, the negative is going to go away because it's going to get squared. So truly, it doesn't matter. So really, let's just square it now, just to get it out of the way. So then that takes care of the negative symbol and the square root. Kind of two birds, one stone kind of deal. So 4y minus 1. We're going to add 1. So this is going to be x squared plus 1 is equal to 4y. Divide both sides by 4. Cancels on the right. So y is isolated right now. Y is by itself. So y is equal to x squared plus 1 over 4. So final answer, we're switching the y to f inverse of x squared plus 1 over 4. All right, number 6. Swapping x and y. 3 square root of y minus 2 plus 4. Okay, solving for the y. I have to subtract 4 first. So x minus 4. Then, right, we're still working our way into the y. I divide both sides by 3. Okay, so then do I have to rewrite it? I mean, not necessarily. Because, right, this cancels. So that's no longer there. So now, on the right-hand side, there's a square root. I got to get to the square root. That means I have to square what's on the right. Therefore, I have to square what's on the left, right? Because whatever I do to one side, I got to do to the other side. All right, so on the right-hand side, we have y plus 2, or y minus 2, rather, right? Because the square and the square root, that cancels each other out, right? This is canceled with that. Left-hand side, x minus 4 over 3 squared. All right, getting y by itself, we're going to add 2 to both sides. So y is equal to x minus 4 over 3 squared plus 2. Hey. All right, that's the answer. That's the final answer. So all we have to do is change the notation, right? Switch the notation. So f inverse of x is equal to x minus 4 over 3 squared plus 2. Is that it for this side? Nice. Okay, the back side. All right, so we want to verify that f and g are inverse functions using composition. So I'm going to compose. So do the compositions and see if you get x. Right. So what we're going to do is we're going to compose f of x and g of x and then see if x comes out. Right? If x don't come out, they're not inverses like immediately. Like all we need to see is that one of these things not produce x, and then immediately it's not inverses. If one of them gives us an x, then we keep going and compose the other one and then see if that one comes out as x. So let's see what this is saying. This is saying that if we take x, plug it into g. So we want g of x, right? Well, g of x, right? G of x is 5x plus 5. That's what it's telling us, right? To compose g with x. X is the input. Input into what? Input into function g. All right. It's given. 5x plus 5. Now, we take g and we plug it into f. So that means the input is going to be g of x. But g of x is what? 5x plus 5. Right, I'm plugging in g of x into f. So everywhere there's an x, I'm putting 5x plus 5. So watch how I do this. F of x says 1/5 x minus 1. 1/5 x minus 1. That's what f of x is, right? 1/5 x minus 1. All right, my input has to be 5x plus 5. So we've done it. We've inputted x. Now let's simplify and see if x comes out. Well, we inputted 5x plus 5. So now let's simplify and see if x comes out. So this is going to be, we have to distribute. So this is going to be 5x divided by 5 plus 5 divided by 5 minus 1. Okay. 5's cancel. 5's cancel into 1. Right, 5 over 5 is just 1. So we're going to get 1 minus 1. That's nice. 1 minus 1, that cancels. So really all that's left is x. So far, it looks good. X came out. Now let's switch the functions. We're going to compose it the opposite direction. So now we're going to take f of x, right? Because that's what it's telling us to do first. So f of x is 1 over 5x minus 1. All right, I'm going to take that. Right, I'm going to take that as my input, 1/5 x minus 1, and I'm going to input it into g of x. Right, I'm taking g of x and I'm making my input 1/5 x minus 1, right? Because that's what f of x is. Okay, so everywhere there's an x, I'm putting 1/5 x minus 1. So g is 5x, right? I'm going to leave a space, plus 5, right? 5x plus 5. That's what g of x is, 5x plus 5. So I want to input 1/5 x minus 1. Okay, Simplifying, we're going to distribute. So this is going to be, 5 times 1/5. So that's cancels, right? That's just x. And then 5 times -1 is -5 plus 5. So -5 plus 5, that cancels. So we got x again. So what happens is we got x in both compositions. Therefore, they are functions. They are inverses. The functions are inverses because the compositions came out to x in both cases. Okay, let's look at another example. So here we have number 8. F of x is equal to square root x plus 2. G of x is equal to x squared minus 2. We want to see if they're inverses of one another. So I'm going to take x. We're going to start with g. So g of x is equal to x squared minus 2. I'm just rewriting it, just so you can kind of see what's happening. Because this is telling us to start with g. Okay, I'm starting with g. X squared minus 2. We're going to input g of x into f of x. So f of x is equal to square root of x plus 2. Now notice I left all these blank. I left them blank because I want you to see how the inputs look. So this is x squared minus 2. Everywhere there's supposed to be an x, we're putting x squared minus 2. So x squared minus 2. All right, because again, we're plugging it into f. That's what we're doing. We took g and we plug it into f. Okay, simplifying this thing on the right. Here's minus 2 plus 2. So that cancels, leaving behind square root of x squared. Well, when you square root, or when you take the square root of a square, those cancel, leaving behind just x. Okay, we can't assume that the next one's going to work out. We have to show the work. So we're going to take, what are we taking? X, and we're starting with f. So f of x is equal to square root x plus 2. All right, the square root of x plus 2, that's my new input. And it's going into g. It's going into g. So g of x is equal to x squared minus 2. So x squared minus 2. Notice I just took out the x's. Where there normally was an x, I took those out. Because I'm replacing those x's with f of x. In this case, the square root of x plus 2. Square root of x plus 2. Okay, calculating the right-hand side. When I square a square root, cancels. We're left with x plus 2 minus 2. And plus 2 minus 2, that's cancels, leaving behind just x. Which means I got x to come out of this composition, x to come out of this composition. Therefore, they are inverses. So both of these are inverses. Had I got something other than x, then it would have been a no. And then you won't have to calculate both of them. The moment you know that it's not x, it's not a function, or it's not a inverse. All right, number 9. So we want to find the inverse of each relation and determine whether the inverse is a function. Hint, switch the numbers. All right. So here we have a set of ordered pairs. So the inverse It's going to be another set, curly brackets. And we're just going to swap the x and the y. 2 comma 4, 3 comma negative 4, 5 comma 2, negative 6 comma 1. Right, all we did was swap x and y. And now we look and see that is the inverse a function. So we're only looking at the inverse, the part in green. Specifically, we want to take note of the x values. Right away, all the x's are different. Yes, this is a function. X's don't repeat. The x's don't repeat. It's always a good reason. X's don't repeat. Okay, let's look at number 10. Again, we are going to swap the x and the y in the ordered pairs. So 2 comma 1, 5 comma 2, 5 comma 5, 8 comma negative 6. We analyze the x's. Is the inverse a function? Well, let's see. 2, 5, 5, 8. Is the inverse a function? No, it is not. Because the x's repeat. Right. 5 came up twice. X's repeat. Okay, number 11. Graph the function f of x. Then use the graph to determine whether the inverse f of x is a function. All right. So what we're going to do is we're going to complete the table. We're going to complete the table, and then we're going to analyze the points and see if whether or not it's a function or not. So f of x is equal to 1/4 x squared minus 1. So let's plug in the x values and see what happens. All right, so 1/4 negative 4 squared minus 1. So negative 4 squared is 16. 1/4 of 16 minus 1. So 16 divided by 4 is 4. 4 minus 1 is 3. Right, this cancels and makes 4. It cancels and makes 4, but 4 minus 1 is 3. So 4 minus 1 is 3. All right, something to note. Let's kind of like think ahead real quick. So we're not thinking ahead, but since I plugged in negative 4 and I got 3, if I were to plug in 4, right? If you were to plug in 4, you're going to get the same answer, because notice that when you plugged in negative 4, when we plugged in negative 4, the square handled the negative sign, right? Because negative 4 times negative 4 is 16. If I plug in just positive 4, well, 4 squared is still 16. So that means we're going to get the same answer to come out. That's kind of nice, actually. All right. If I plug in negative 2, so 1/4 negative 2 squared minus 1. So negative 2 squared is going to be positive 4. So 1/4 times 4 minus 1. So 1/4 times 4, well, that's just 1. And then 1 minus 1, well, that's 0. So when I plug in negative 2, I get 0. For the same reason as mentioned, when I plug in positive 2, I'm also going to get 0. All right. When I plug in 0, this is nice because 0 squared is 0. 0 times anything is 0. So 0 minus 1 is negative 1. This is going to be negative 1. Okay, so now I'm going to write out in set notation the ordered pairs. Just like up here, right? Just how we did with 9 and 10. I'm going to have ordered pairs because that's what these are. These are ordered pairs. So I'm going to have negative 4, 3. I'm going to have negative 2, comma 0. 0, comma negative 1. 2, comma 0. And then 4, comma 3. And this is my set. Okay, if I want to take the inverse, I'll do the inverse in red. All I have to do is switch the points, just like I did for 9 and 10. So now we have 3, comma negative 4, 0, comma negative 2, negative 1, comma 0, 0, comma 2, and then 3, comma 4. Inset. All right, we have to plot these. So if we plot these points, we're going to get, so 3, negative 4. So 3, negative 4. There's 3, negative 4. 0, comma 2. Or, sorry. Well, 0, comma 2 is here, but 0, comma negative 2. That's what we wanted. 0, comma negative 2. Negative 1, comma 0. So net left 1. And then 0, comma 2, I did that one. And then 3, comma 4. 1, 2, 3, comma 4. All right. We plotted the inverse. So it kind of looks like a sideways, kind of like a C. So we want to use the vertical line test. So I want to pass a vertical line through the points. And if the line touches more than once, then it's not a function. So right away, right now, it fails the vertical line test because the line passed through 2 points. So not a function. Right away, not a function. All right, hopefully this helps someone out. Catch you in the next video.